Derivatives of exponential functions. So two rules. The first one is the derivative of e to the x is still e to the x. This is a very special case. For e to the x, it doesn't matter how many times you take the derivative, you still have e to the x. And then the other one is a raised to the x. You don't see this very often as we move on to further lessons. A raised to the x. Usually you see e to the x. So for a to the x, a is a constant, x is an exponent. So that's why dx, we are taking the derivative with respect to x. Two different ways to write it. You can write ln a and then times a to the x. So basically you copy a to the x one more time and then you multiply ln a. So this one a to the x times ln a. Again, you copy this one more time and then you write ln a. So let's do some examples. The first one is y equals to ax squared minus 4e to the x plus 9x minus e, and then the derivative. So for number one, and then y prime. So I should change this. So 1, what's y prime? So simple power rule, you bring the 2 down, right? So that is 16x. 2 minus 1 is 1. And then the derivative, e to the x, still e to the x. So that is 4e to the x. 9 raised to the x power. So this one you write ln 9 and then multiply 9 to the x. The derivative of e is 0 because e is just a constant. E to the x has a variable. E is just a constant. E is approximately equals to 2.71. So minus a 0. You don't have to write a minus 0 out. And then number 2. So number 2, we have f prime of x. So we have b to the phi x. This one we have to take a step. Don't move on yet. I will rewrite the phi b to the phi x as b to the 5th power. So this is a constant. So now I raise that to the x power and then minus a to the negative 10. So as one constant and then raised to the x power. So now I apply the rule and then f prime of x, that is equals to, so you write the whole thing again. So b to the phi x, and then in front of this term you ln the base, so which is ln b to the 5th, and then usually they put that in a parenthesis. And then for the second term, you copy the whole term again, so which is b to the negative 10x, and then you ln the constant, which is ln b to the negative 10. And then you learn this from your pre-calculus and intermediate algebra. For the ln term, if that there is an exponent, you can bring the exponent down. So f prime of x is equals to phi times ln b, and then times b to the phi x minus, you bring the negative 10 down, that becomes a plus 10, and then ln b, and then multiply b to the negative 10x. Okay, so number 3, we have so we have g of t equals to 2 to the x plus a to the t. All right, so a to the t, a is a base, plus pi square, and then g prime of t, that is equals to, so that one follows the a to the x, so you write this one more time and then ln 2, and then the a to the t, same thing, so you write ln a and then times a to the t, and then the pi square, the pi is a base, and then pi square is just a constant, so which is just a 0. Pi square is just a constant. So that's it for number 3. And then number 4. So number 4, we have f prime of x. Let's just do the derivative right there. E to the pi, is this a constant? Yup, it's a constant. X to the pi, exponential or power? X is the base, right? So that one is not exponential. X to the pi power, that one is a simple power rule. You bring the pi down, x to the pi minus 1. So pi, let's make that look like a pi, shall we? Pi minus 1. And then the pi to the x is exponential. So you add ln pi and then multiply pi to the x power. They usually use a parenthesis, not a pi. So this one, you can use a parenthesis right here and then right here. So that's number 4. And then number 5. So let's do a number 5. Let's pick orange. So for number 5, so we have a z prime. So that is a 5 to the x, ln 10 times ln 5. So ln 10 times ln 5. And then the x to the pi square, that one is not exponential because the base is the variable. And then you add pi, you bring this down, right? So you bring this down, and then we did a similar one before, right? Where is it? 1, 2, 3. Yeah, right here. Number 4. We brought the pi down, and then pi minus 1. So this time you bring the pi over 2 down, and then x to the pi over 2 minus 1. And then the last term is the exponent is x, so that one is exponential. And then we subtract, we copy the whole thing first. So pi over 2 raised to the x, and then we do an ln pi square. For the ln pi square, you can bring the 2 down in front of the ln. So that is the same thing as, this is the same thing as 2 ln pi. Alright, so that's the 5 example and the derivative of exponential function. If you think this is helpful, give me a like, share, and subscribe, and I will catch you all in the next video for more examples. Signing out.